What's up, everybody? What's going on? Okay. So, ladies and gentlemen, boys and girls, this is me, Yawar Manzoor, and I welcome you to JEE English Unacademy. Okay. If you haven't subscribed yet, just hit that subscribe button right now. Okay. And press that bell notification because you'll be getting the update whenever we come live. And ladies and gentlemen, today we're gonna be talking about that is nothing but dielectrics. Okay. Capacitors with dielectrics. Okay, we're gonna be talking about this, what exactly this dielectric is, and what is why do we use basically these dielectrics in case of these capacitors. Everything we're gonna be talking about in detail. And there are two important cases that we're gonna be talking about. That is nothing but this insertion of this dielectric when battery is not connected and insertion of this dielectric when battery is connected. Okay, so we'll have to learn these two cases in the detail. Before that, I just need to know in the live chat how many of you are feeling great today in the live chat itself, and hit the like button as soon as possible because that is mandatory. You have to mark the attendance before we start this lecture. And ladies and gentlemen, this is a piece of information about me. My name is Yawar Manzoor and I am exactly from Kashmir, okay? And I'm a JEE Physics expert. Piece of information about me, definitely over here. And now, apart from this YouTube platform, we teach on Unacademy's own platform, okay? We teach on Unacademy's own platform. Over there, if you want to learn from us, if you want to learn from country's top educators, because over there inside Unacademy, country's top educators are teaching you. So if you want to learn from all of those top educators inside Unacademy, you have to take this plus subscription. You have to take this iconic subscription. This is mandatory, okay? Now you'll ask, sir, what are the benefits that we're gonna get if we take this plus subscription and if we take this iconic subscription? See, in this plus subscription, you'll be getting live classes, weekly tests, structured courses, unlimited access. Means every single day you have the live classes over there. There are so many top educators from the entire country, from the entire quota who are teaching you over there. Okay, so this is basically you can watch anybody's lecture, and this unlimited access means you can definitely watch anybody's lecture in a particular category. If you take the subscription from IIT JEE category, if there are 100 number of educators who are teaching you over there, you can watch anybody's lecture. Okay, that is basically the benefit of that. And weekly tests, every week you will be getting the tests, structured courses. And apart from this, if you basically take this iconic subscription, you will be getting all the benefits you get in plus, and there are some extra benefits as well that you get in iconic. That is what? That is personal guidance. First of all, you'll be getting all of these in iconic as well. And there are some extra benefits in this iconic. That's why we call this iconic. That's personal guidance. Means an educator will help you throughout your exam, how you can basically crack it. If you need any sort of clarifications on any damn thing, he'll definitely help you. Yes, I know you are from Tamil Nadu. Good evening. What's up? Okay. So you go to school every single day, school, college, whatever you say. And this iconic subscription, if you take this one, you'll be getting the test analysis. Means once you are done with the test, afterwards you need to analyze your scores, in what portion you are lagging in what portion you need to focus more, so that you will get good scores in the upcoming mock tests. Okay, so this test analysis is done from our end. Our educators, our experts will basically analyze your scores, in what portion you are lagging. So this all comes under iconic. If you take this subscription, you'll be getting this option as well. Understand? And this is the experts guidelines, how you can crack the exam, tips, tricks, everything comes over here. Study material, branded study material is delivered to your doorstep, that too in hard copy, no, not a soft copy. Okay, this is the study planners. Okay, and if you want to follow me, you can definitely follow me on Unacademy. This is my username. Every single time we come up with the classes over there. And tonight also at 8 o'clock exactly, we are coming up with the previous year questions of JEE mains from electrostatics. This is a part 2. Okay, I suggest you to join me over there. We'll kill some of the beautiful questions. It will be only 50-minute session. We'll be basically solving so many problems in just 50 minutes. Okay, and the next thing over here is these are the batches which we have launched recently. Okay, no, these batches will be starting from tomorrow onwards, okay, because this is from 15th. Okay, we haven't launched any of the batches yet. So this is Shine 2.0. This is completely in English language, and this Spark 2.0 completely in English language. So if you are looking for joining these batches, do it right away, because right now 20% discount is going on. Okay, so as compared to the other days, normal days you'll be getting only 10%. Right now in this week itself you'll be getting 20%. 10% by using my code, and 10% is the special weeks offer. Okay, so go for this one. If you are appearing for JEE 2022, definitely you should go for this one. If you are appearing for JEE 2023, you should definitely go for this one, Spark 2.0, if you want to learn in completely in English language. So this is for that only. And these are some of the other batches which are basically top educators are running these batches. So I suggest you to join these if you want to learn from those top educators. Now the point over here is, if we join these batches, for how much amount of time we can take this plus subscription. You can take it for 3 months, 6 months, 12 months, 18 months, 24 months. If you take this for 3 months, 6 months, 12 months, there are EMI options available as well. You don't have to pay the entire amount at once. You can pay it every single month. Okay, so this is the price for 12 months, this is the price for 18 months, and this is the price for 24 months. By using my code, you can definitely get the maximum possible discount. By using this code, you can definitely get the maximum possible discount. This is the code that you can exactly use. The second thing over here is that iconic subscription, if you take this for 12 months, you will be getting what? It for this much of money, for this much of, for this much for 24 months. Now, if you want the maximum possible discount, you can use my code. Okay. Now, I'll just tell you how much exactly discount you can get by this week itself. If you take the subscription in this week itself, you'll be getting 10% off. That is the week's discount. Okay. In this week only. And by using my code, that is this Yawar, you'll be getting extra 10% off. Extra 10% off. So means total you will be getting 20% discount by in this week only. So if you are looking for taking the Unacademy's iconic or plus subscription, then I suggest you to take it in this week only. Okay. Now, this is basically the Unacademy champions. Okay. So Unacademy wants to take this chance to give back to its champion learners. Okay. So this is IIT JEE 2021 aspirants. There is a Google form in the description below. You just need to fill that up. You'll be getting the cash reward. Okay. Just fill that Google form. And ladies and gentlemen, this is one of the beautiful features of Unacademy, that is Ask a Doubt. I'm good. What about you? So that's Ask a Doubt. If you have any sort of doubt, you can definitely ask on Unacademy. Even you can ask unlimited number of doubts. This is one of the beautiful features. That's why. Okay. And you can ask the doubt any damn time. You'll get the solutions, that too high quality solutions, that too in English language as well as in Hindi language. The next thing is you'll receive the exact match of your solutions. And this, how you can exactly ask that out, there is an option doubts and solutions on Unacademy app. Over there, you just have to click the picture. That picture should be completely clear. It should not be blurred. Understand? And you have to crop that particular doubt. It's not like you'll send 5 or 10 doubts at once. No, you just have to crop that particular doubt so that our educator will not get confused which doubt I am supposed to solve in this one. So you'll get that solution within no time for sure. Okay. And these are the do's and don'ts which you need to follow while you basically ask a doubt. Okay. The next thing is, ladies and gentlemen, that we're gonna be talking about by today itself. That is this capacitors, dielectric in capacitors, capacitors with dielectrics. Okay. First of all, I'll explain you what this dielectric is all about. Why do we study this dielectric? Where does it come from? I have already explained this in electrostatics. If you want to learn about this dielectrics in detail, then I suggest you to watch my second lecture of electrostatics, Coulomb's law. You can just search it in the search bar itself. You just write Yawar Manzoor, Coulomb's law, JEE English Unacademy. Over there in that lecture itself, I have completely explained this dielectric. Okay, so I suggest you to go over there. Permittivity. Okay, relative permittivity. Okay, how was it? Okay, fine. Now, capacitors with dielectrics. First of all, let's talk about these dielectrics. What these dielectrics are, let me just give you the feel. Okay, from the electrostatics itself. If I say, for example, I have a charge over here, listen to me very carefully. Okay, I'm taking you back to your basic level, back to your previous level, electrostatic level. Listen to me very carefully. If I say I have a charge over here, that is nothing but this is Q1. If I say I have another charge over here, that is nothing but Q2. You'll simply say they'll start repelling each other. If both the charges are positive, positive repel, okay, they'll start applying force on each other. If they are positive and negative, unlike charges attract, they'll attract. If we say these are basically what? The charges at r distance, they are basically positive charges. We say this will force between the force of Coulomb's force will be between these two. We have studied this. That is nothing but how much? 1 by 4 pi epsilon naught q1 q2 by r square. Understand? This much of force they will apply on each other. We have studied this till now. Okay. Oh, that's great. Okay. So we have studied this previously. How much amount of interaction will be between these two charges? That is this much. Okay. 1 by 4 pi epsilon naught q1 q2 by r square. Previously discussed properly. Now, if I ask you the simple question over here, I'm taking these two charges, I'm placing it in free space air over here. How much amount of force they will apply on each other, exert on each other? You'll simply say, sir, that is 1 by 4 pi epsilon naught q1 q2 by r square, because this epsilon naught we take in free space only. Understand? This is permittivity of free space. Fine. When we place this in free space, we take this epsilon naught, because this epsilon naught permittivity of free space only tells us how much amount of force they will apply on each other. So it depends upon this medium. Understand? Now, if I ask you this question, I'm taking the same two charges, I'm placing it in some medium. Understand? Water, whatever it is, other than free space, vacuum, okay, like water or glass, mica, whatever it is. If I ask you the question, what will be the force in that case? You'll simply say, sir, the force will be nothing but if we place the same two charges we are placing in some other medium. This is a medium. Okay, this is Q1 and this is Q2. R distance between these two. What is the force between these two? In this case, you will simply say, sir, this force will be nothing but that is 1 by 4 pi epsilon Q1 Q2 by R square. Understand? Where epsilon is what? Permittivity of that medium. In that medium, how much amount of force they will apply on each other? Who is going to tell you this? This epsilon. Understand? In air, how much amount of force they will apply on each other? Who is going to tell you this? This epsilon naught. Understand? Everybody is able to understand this one. This is very simple. I have clearly explained this previously. So epsilon will tell us how much amount of interaction will be between these two charges. So completely depends upon this one. Understand? Now, we say more this epsilon, more this permittivity, less will be the force. If we increase this, less will be the force. Understand? Because in any medium, we say force is less as compared to the force in free space. Because this is medium less over here. Consider it medium less. Don't say there are air molecules, something like that. We consider free space, or we say this is a vacuum only. Okay? Fine. Now, the point over here is, listen to me very carefully. Listen to me very carefully. There are 2-3 equations that I'll be explaining you in this case only. Okay, let me just write it over here. There is one more term that I have told you previously. What is that? See, this is what? This is nothing but, this is permittivity of that medium. How much interaction will be between these two charges? This permittivity of this medium will tell us. More the permittivity, less will be the force. Understand? More will be the medium over here, that molecules and all. And in this case, this permittivity of free space will tell us. Now, there is a term that is what we call the relative permittivity, that is ER. We said this relative permittivity is nothing but that is permittivity of this medium upon permittivity of any medium, upon permittivity of free space. Now, see, this relative permittivity is telling us what is the permittivity of any medium as compared to the permittivity of free space. Listen to me very carefully. If this is a medium over here and this is free space, air, if I ask you what is the permittivity of this medium, how are you going to define it to me? You'll say, sir, I don't know. You'll say basically the permittivity of this medium will be how much more permittivity this has as compared to the permittivity of free space. How much more permittivity that has as compared to the permittivity of free space. Or we define it like this also, that is this force in any medium. If you want to check the force in any medium, you say basically force in free space upon a relative permittivity. Understand? Listen to me very carefully. This is one of the important points that I'm telling you right now. So what is this? How much, if I ask you how much is the force over here, you'll check. The force in this one will be the force in air. The force in this medium will be force in air divided by what? Relative permittivity. Understand? How much force has been decreased? This equation is telling you how much force has been decreased in any medium as compared to the force in free space, because force in free space we take it large, okay, as compared to any other medium. So this relative permittivity, simple. From now onwards, listen to me very carefully. From now onwards, listen to me very carefully. We say this relative permittivity is nothing but it tells you how much permittivity does a medium have as compared to the free space. Point number one. Point number two is this relative permittivity is telling you how much force does the two charges apply on each other in any medium as compared to the free space. How much force does the two charges apply on each other as compared to the force in free space. Understand? Getting me? So this is the permittivity that is basically telling you. Obviously, in that medium, force will be less. Understand? Permittivity increases, force in that medium will basically decrease. Fine. So this permittivity, this medium, understand this what? Relative permittivity, we call this as a dielectric. Understand? This is what we call the dielectric. Understand? Dielectric. Simple, in simple words. And we call this dielectric, we represent, some people represent with it K also. Some people represent with it K also. You got the feel of what is this dielectric? What is this dielectric telling you from now onwards? If we say, for example, I'm placing the two charges in dielectric, means this dielectric will tell you how much amount of force will be reduced between these two charges as compared to the force in free space. Nobody is gonna explain you like this, for sure, 100%. Come on, in the live chat, I just need to know you got the feel of this one. Okay? This relative permittivity, this is what we call the dielectric. Fine? You getting me what I'm trying to say? Now the question comes over here is, just remember these two formulas, okay? Just remember these two formulas. I have explained this clearly in the lecture number 2 of electrostatics. Okay? Now, listen to me very carefully. That is, why do we use these dielectrics in case of? Okay, now you'll say, sir, these dielectrics are these conductors, insulators. We say it is some sort of insulators only, okay? These are not the conductors, okay? But there is a little bit of conduction, okay? Now, different people will have, sir, no, sir, there is no conduction in that case. Okay, chalo, we'll basically say it accordingly. Fine. So why do we use these dielectrics? Now the point is exactly like that in case of capacitors. Okay, we understood what is the dielectric. This is nothing but that medium dielectric constant. We say K, relative permittivity, everything. Sir, your electric potential lecture was amazing. Thanks, man. Every lecture of mine is amazing, I guess, because I start from entirely basics. I give the exact feel. I haven't started any batch on Unacademy yet. I'll start it very soon. Don't worry about that. Chill scenes, man. And how is the PPT today? Is it fine, or you want it like the yesterday's PPT? Okay. Now listen to me very carefully. If I say, why do we use these dielectrics in case of capacitors? See. If I say, for example, there is a capacitor over here. This is a parallel plate capacitor, okay? I'll just try to make this parallel plate capacitor over here. So this is one of the plates and this is second plate over here. Fine. If I say I'll connect the battery to it. If you have any sort of confusion, what is this parallel plate capacitor, capacitance, everything, then watch the first lecture of this one, okay? If I ask you, simple question over here. If I connect, this is uncharged capacitor. If I connect the battery to it, what will battery do? That will take the electrons from this plate and will shift to this plate, understand? Or that will shift the DQ charge from this to this, whatever it is. Eventually, what happens after that, that will charge the battery because shifting the electrons from here and will place it over here. So this will become negatively charged and this will become positively charged. Explained this in the lecture number 1 very in a detailed manner, okay? This is positive, this is positive. So eventually, I would say this is the positive charge will over here, come over here. This is the negative charge on this one. On this plate, positive charge will occupy. On this plate, negative charge will occupy. Now the question over here is, I'm saying that there is a positive charge, there is negative charge. So between this, there will be electric field. And between this, there will be force because this is positive charge. This is positive, negative attract each other. Okay. So these two will basically start attracting each other. And when there is nothing in between these two, there is a vacuum, nothing is in between these two. So they will basically attract each other. They'll stick to each other. Understand? So what is a capacitor? Capacitor basically, there should be something. This is a plate, this is another plate. Between these two, there should be some gap. Understand? It should be very small, but there should be some gap. Understand? So now the point over here is they will stick to each other. It will not basically remain as a capacitor. We cannot call it as a capacitor. Fine, they'll stick to each other. Now, if we want to basically keep them at some distance, what we are supposed to do, we'll put some material in this one that will basically keep both of these plates at a some distance so that they'll not stick to each other. This is simple logic over here. That's why we basically use a dielectrics. We'll basically put the dielectric in between. I'll just show you like this. This is a dielectric slab, or you'll say some medium, whatever that is, okay, some medium slab, whatever it is. So you will put the dielectric over here. So because of this dielectric, they'll remain away from each other at this distance d. So we call them this as a capacitor. That's why we use these are dielectrics. Now you will have question in your mind, how do exactly metal plates not stick when we basically place the dielectric inside this? So that is the main question that you need to understand in this one. Come on, everybody liking this lecture? Okay, fine. If I say on this plate, charge Q is present. On this plate, negative charge is present. How? We connected the battery that took the electrons from here, shifted on this one. So negative charge occupies over here, positive charge on this plate. So now they will start attracting each other. Now, when we basically place the dielectric in between, so there are some over here, I would say there are some ions of this dielectric for some just involve the chemistry over here as well. Okay. Okay. Now, if I say, for example, inside this dielectric, there are some positive charges, negative charges, positive charge, so many number of positive charges, negative charges. Now, what happens over here is this positive plate will basically attract all of those negative charges which are present inside this dielectric. So that will basically occupy somewhere around over here on the left side of this one towards this positive plate. Okay. Initially, what was happening? This plate was attracting this one. So finally, we placed the dielectric in between. Now, this plate started attracting the charge, negative charge, which is inside this dielectric. Okay. And the positive charge will be exactly shifted somewhere around here. Fine. Now, the point over here is they will basically interact with these. These charges will interact with these. Understand? So inside this also, there will be electric dipoles. It will align in the form of electric dipoles. What happens over here is when this plate is attracting this positive charge that is being shifted towards this, and this charge is being shifted towards this. So we say what happened? The polarization of this dielectric exactly happened. This is what we call the polarization. Okay. So yeah, exactly. It also provides the stability. That's what I'm trying to say, stability. Stability so that they'll not stick to each other. Now, if I say in this case, polarization will happen over here, 100%. So when polarization happens over here, this will be attracted, this will be attracted. So this polarization happens. Now they will start interacting with these charges. This will basically start interacting with these charges. So over here, they will form some sort of electric dipoles. And that electric dipole will be basically in the direction of electric field. It says, sir, external electric field, that's what I'm saying, between this plate and this plate, that's what we call the external electric field. I'll just represent that with this E, external electric field. And what happens inside also, there will be inside, this is positive charge from one side, negative charge from one side. So inside also there will be electric field, that is electric field induced inside, from the inside of this dielectric. So what happens? Electric field will be basically produced. So that electric field will try to kill this electric field, understand? So when this electric field is reduced, they will start interacting with each other. They will stop interacting with each other so that they'll not stick to each other. You getting me what I'm trying to say? So what exactly? Yeah. It allows the development of electric field. That's what I'm trying to say. Yes. See. That's what I am saying. There are whatever some electrons it will have, some positive charge, negative charge it will have, understand? So that will be attracted, very less amount of the positive charge and negative charge, understand? That will be attracted from this side and this will be attracted from this side. This is not a conductor, okay? These are the conductors. these will have excess amount of electrons, but this is not the conductor. Some amount of charge, I would say, over here. This is a, you take this as an insulator. Understand? So when this is an insulator, so some of the charge will, which is present over there, understand, that will be shifted towards this side. Haven't you studied my conduction video? Okay. Watch that when you'll get the feel of that exactly. Okay. So basically, the induced some internal electric field will be created over here. That internal electric field is trying to kill this electric field. That's why interaction between these two plates will basically reduce. Understand? Now, if we go back to our electrostatics, if I say, for example, this is a charge, okay, this is a charge Q. Let me just show you over here. If I say, for example, this is a charge Q over here, this is a charge Q, and this is a charge Q. Okay, this is charge Q, this is charge Q. This is in free space. They are interacting with each other with a Coulomb's force. F is equal to how much? F is equal to K Q1 Q2 by R square. Now, when we are basically placing these two charges in dielectric, understand, in any medium, we say this is Q1, this is Q2, understand? So in this case, they will start what? The force will reduce. How force is exactly reducing? So this dielectric is basically, this medium is basically creating its own field. This is permitting its own field. That field is trying to reduce the interaction between these two charges. That field is trying to kill the electric field between these two charges, and that's why this electric field is reduced between these two charges. That's why electric field reduces. That's why main electric field reduces, interaction between the two charges reduce, and force between the two charges reduce. What is the exact matter? Exact matter is between these two charges inside the dielectric, this dielectric is creating its own electric field. Understand? Development of its own internal electric field. That electric field is trying to reduce the interaction between two charges, trying to kill the interaction between these two charges. That's why force reduces. Now you got the feel of this one. Hey, you can take anything. You can take the dielectric of glass, whatever it is. Fine. You got it now? Now, so this is the case over here. Now we need to basically do some sort of derivations. That's all. This was the concept over here. Yeah. Fine. Now, can I say in this case, what will be the net electric field? Electric field will be induced from the inner side. So net electric field between the plates now after putting the dielectric, you'll say, sir, this is the external electric field between these two. Initially what was, understand? After putting the dielectric, this is creating the internal electric field. So I would say this E net will be nothing but the external electric field between these two. That will be obviously more because this is a conductor, okay? So that will be minus of this E minus E, that which is internal, which is from the inside, okay? Can I just write it like that? I'll tell you everything, okay? Yes, everybody like the video as soon as possible. Yo. Okay. Now, what is the electric field? If I talk about the electric field between in a parallel plate capacitor, have you studied that? Because of this one sheet of charge, when we were studying the Gauss law, okay, in that case we basically found the electric field because of this sheet of charge. How much that came out to be? That is, electric field is nothing but that is sigma by 2 epsilon naught. Because of this sheet of charge, it will be also that is this plus sigma by 2 epsilon naught. So can I say this electric field will be nothing but sigma by epsilon naught exactly. So because of this one, it will be because of this one between these two electric fields. Now electric field induced, can I just write it like that? It is nothing but sigma naught, where this is the internal charge density, whatever is inside in that dielectric upon this epsilon naught, okay? Let's move. New capacitance after dielectric. Can you tell me what is the new capacitance after dielectric in the live chat itself? All of you. I just need to know, man. I just need to know, man. Yo, that's great. Okay, now let's talk about the capacitance now. Let's talk about the capacitance now. So, in case of the parallel plate capacitor, this is a parallel plate capacitor without the dielectric. I have told you in the lecture number 1, what was the capacitance we have derived. What is the capacitance? What is capacitance? Capacitance is now the ability to store the charge. Okay, how much ability does it have to store the charge? How much that came out to be in case of this capacitor, polar plate capacitor? It says, sir, that is this C, that is sigma A, this epsilon A by D. Understand? This C was basically constant. We defined that it depends upon the area. It doesn't depend upon the potential or the charge occupied on the plates. It depends upon what area of that plate. It depends upon epsilon, not medium. It depends upon what? The distance between the two plates. We have discussed this previously. Yes, we have discussed this previously in detail. Now, this is the capacitance without the dielectric. Now I'm asking you, I'm placing the dielectric between the two. I'm placing this dielectric between these two plates. Afterwards, what will be the capacitance? You will say, sir, there will be new capacitance. What will be that? You'll say, sir, that is new capacitance C dash, okay? Between the two plates, I'm talking about now between the two plates, dielectric is filled. It's these two plates, between that space is basically filled with dielectric now. So this is, you will say, sir, it is nothing but instead of this epsilon naught, now there is dielectric, medium is there. So can I say that I'll write E in that case? So this is nothing but what? E, permittivity of that medium. And this will be nothing but A. What is the area? Area will remain same of these two plates, okay, area. So this is permittivity of this medium, that is epsilon. This is epsilon, not E. This is epsilon upon this D. Distance between the two plates will also remain same, So can I just write in this case the formula that I told you in the beginning itself, that is ER, relative permittivity, is equal to epsilon, that is permittivity of any medium, upon permittivity of free space. Means if you want to find the permittivity of any medium, you check how much relative permittivity is over there, multiply that with what? Permittivity of free space, you will get permittivity of any medium. Understand? If you want to find that, how many times the permittivity of any medium is more than the permittivity of free space. That is what I'm trying to say. This E of any medium is nothing but E naught into ER. If you want to find the permittivity, how much electric field it can create, you can call it like that also. How much electric field it can create. Okay, how much electric field it can create in order to reduce the external electric field. You can basically define it like this also. So how much electric field it can create, or how much interaction, how much permittivity will be in that in any medium as compared to the permittivity in free space. That is this one, relative permittivity into this one. Okay, so can I just write in this case, this will be nothing but C dash is nothing but, instead of this, this is epsilon of any medium, permittivity of any medium, that is epsilon naught into R. Can I just write epsilon naught into this epsilon R, and this is A upon this D, 100%. So this C dash will be nothing but, take this epsilon R out. So this is nothing but epsilon naught A upon this D. What is this epsilon naught A by D? Epsilon naught A by D, that is the original capacitance, initial capacitance. So can I say this C dash will be nothing but ER, that is this ER multiplied by C. This was the initial capacitance when the dielectric was not present. So can I just write now this C dash will be nothing but ER, we say dielectric constant, ER or K, okay? So K times of C. ER, either you write ER, either you write K, it's one and the same thing, okay? So this is the new capacitance. So capacitance has been increased by K times, means the relative permittivity times, dielectric constant times. If you are putting the dielectric over there, so what is the dielectric constant of that? So capacitance will accordingly increase. Now you got it? Why K times increase with capacitor? This is the proof over here. Because till now I was explaining this only. What is this relative permittivity? Understand? Okay. So this is all we have over here. Fine. Everybody understood? Come on, in the live chat itself, I just need to know. Okay. Yeah, I just need to tell you one more thing, okay? Over here. Like, see, if we talk about this one, if I say, for example, I'm taking these two charges Understand? So I'm placing it in air. What is the force? Force is F naught. That is F naught 1 by 4 pi epsilon naught K1 Q2 Q1 Q2 by R square. And if I ask you how much is the force in any medium, you will check how much is the relative permittivity and how much is the force in free space. So F naught divided by this. Understand how much the force has been decreased in any medium as compared to the force in free space. Understand? So that is what is define the force in any medium. So can I exactly say it like that? After placing the dielectric over here, after placing the dielectric, so initially how much was the electric field? You will say, sir, that is nothing but E. So finally, how much is the electric field? You will say, sir, that is this final electric field after placing the dielectric. What happens with the force? Electric field in any medium. So that is nothing but what? What happens? Exactly like this only, na? This, that is F naught, that is E naught by ER. Can I say this E naught? That is electric field without this dielectric. See, if I say without dielectric, electric field between this is E. So after placing the dielectric, what happens with the electric field? You will say, sir, that new electric field will be nothing but E by K. This is reduced by K times. This is reduced by K times. Just remember this, okay? Fine. Fine. Okay, let's move on to the next one. Just let's move on to the new one. Fine. See, I got this, but this is the clear proof. You are not getting it properly. Capacitance is what? Ability to store the charge. You can understand it by that way also. Understand? So that ability will obviously increase in this case. Understand? Storing of that charge. Storing. Understand? How much ability does it have? Try to get it. Understand? Because it depends upon the medium. Capacitance depends upon the medium. Understand? So if it depends upon the medium, obviously it will change. Nah? E, this epsilon naught A by D depends upon the area. This D. So capacitance has to increase because medium, it depends upon medium. That's why. Try to get it like that. Now, energy density we need to find out in this case. What is this energy density all about? Everybody getting this? Fine. Now see, energy density. Okay. What is this energy density? We say energy density is nothing but you represent it with mu. It is nothing but energy per unit volume. Okay, we say charge density, charge per unit area, charge per unit length, charge per unit volume. If I say, for example, this is a rod over here, this is a rod over here. Okay, if I say the charge density of this rod is nothing but lambda, how do you define it? That is nothing but Q by L. Charge per unit length. On its per unit length, how much amount of charge is present? You don't know the charge present on the entire rod, for example. So you can find the charge per unit length on this rod. Understand? That is on its unit rod, on its unit length, how much amount of charge is present. If, for example, I say now Q charge is present on this entire L length, so I will define that lambda is equal to Q by L. Same is the case over here. Energy density. How much energy is present in per unit volume? Now you will say, sir, why are you taking the volume over here? Not the length, something like that only. 1 second, man. Now see, if I talk about these two polar plate capacitors, I'm just making the polar plate capacitors over here. 1 second. Okay. These are exactly something like this only. Okay. Now see, between these two parallel plate capacitors, this is, you can understand it something like this. Okay. This is, you can understand it something like this. This is a plate 1, this is plate 2. Between these two, there is a volume. Okay. This is a volume. Understand? Present. So how much energy you can store in this volume? That is what? Energy density, energy per unit volume. In this one, how much amount of energy you can basically store. Understand? So energy per unit volume, on its, in its per unit volume, how much amount of energy you can basically store. That is energy per unit volume over here. Now, can you tell me exactly how can we exactly find this one? See, this is energy per unit volume. Volume we can exactly find. That is area. area of these plates multiplied by, if I say density, basically this distance between these two plates is D. Understand? Area of this is nothing but, if I say for example A multiplied by D, area into length, area into this distance will give me the volume. Now the point over here is, how can we find this U? U is what? U is energy stored in this capacitor. How can you find the energy stored in the capacitor? In the last lecture we have discussed this 1 by 2 CV square or Q square by 2C. Clearly I have told you every damn thing about this one. So we know that U is nothing but that is Q square by 2C, clearly previously. Now how can you find the Q over here and how can you find the C over here? Capacitance, this is the energy in terms of charge and capacitance. In terms of C and V, that was 1 by 2 CV square. There was some other formula also, I forgot that. And this is Q by 2C, Q square by 2C. Now if I ask you how to find this over here, you say if there is a positive charge on this one, this is a negative charge on this one. Okay, this is positive, 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 negative, negative, negative. So between this there will be electric field. I can tell you the electric field. So how much will be the electric field? You will say, sir, this electric field in this case, how much will it be? Can you tell me in the live chat? That is sigma by A. But in case of parallel plate, this is a parallel plate, sigma by A. Hey, here I got this now. Sigma by epsilon naught. Sigma by epsilon naught. So can I just write this is nothing but sigma by epsilon naught? Understand? And further, sigma is what? Charge per unit area. On its unit area, how much will be the charge present? You will say on its unit area, how much will be the charge? Because this is a sheet. On its unit area, how much will be the charge present? Everybody getting this one? So can I just write in this case, this is nothing but charge per unit area. That is how much charge is Q. If I say Q charges on this one, this is Q and this is minus Q over here. Okay, so Q charge is present on this one. So Q upon this is epsilon naught. This will be A exactly. So from here you can exactly find this Q. So can I just write this Q? It will be E multiplied by this epsilon naught multiplied by this A, 100%. Now the second point over here is, how can we find this capacitance? Capacitance in case of parallel plate capacitor. I told you, okay, few minutes back and previously also. So in case of parallel plate capacitor, how can we find the capacitance? That is nothing but epsilon naught A by D. Understand? It depends upon these things. Okay, epsilon naught A by D. So we got these things. Now can you put it over here? 100%. So I'll just write it over here now. I'll just write it over here. So can I just write in this case, this U will be nothing but 1 by 2. Take this 1 by 2 out. Instead of this Q, what I will put, that is this. This is Q square. So it will be nothing but E square, this epsilon naught square, this A square, this square, this A square. Okay, upon. And this will be what? This C, 2 into C. So this is 2, 1 by 2. So can I just write 2 into C? That will be this epsilon naught, this A by D, exactly 100%. So this will cancel. This will exactly cancel. Yes, it will go up. So U will come out to be 1 by 2. This will be E square and this will be epsilon naught. This will be A and this will be D. So we got this energy. We got this potential energy, or you say energy in case of this parallel plate capacitor. Now we know the volume, area multiplied by this distance. Understand that we can find the volume. So can we find this U exactly? Can we find this U? Now we can find this U, this energy density, this U, that will be nothing but this 1 by 2 E square epsilon naught A multiplied by this D upon this will be A into D. Why? Because volume is A into D. This will cancel. So this will come out to be 1 by 2 E square and this epsilon naught. Understand? So this is basically energy density over here. Now if I say, if there is a dielectric present, medium is present, so in that case you will define, this is epsilon naught. In case of free space, no spaces, no dielectric is present, no medium is present. In case of that, can I just write U of that K is nothing but 1 by 2 E square, and instead of this, I'll write epsilon, means permittivity of that medium. This is epsilon. Okay, fine. You got it? Okay. This is the energy density in this case. How do we exactly get this energy density? This is a capacitor. Energy per unit volume. On its unit volume, how much energy is present? Understand? Okay, fine. Now see, This is energy per unit volume. First of all, we got the energy. How much is energy? That is Q square by 2C. Previously, we have studied this. Then we got how much charge is basically present. That is, we need to find this Q and this C. So that is from electric field. We know this is a positive plate, this is negative plate. There will be electric field. So we can find that electric field in case of polar plate capacitor studied previously. Understand? So this is a positive plate. Because of this, it will be create electric field. Because of this, it will create electric field. Understand? So we can find that electric field by Gauss law. We can find that electric field by Gauss law. We can combine that. We can exactly get this one. So this is the derivation over here. So finally, you can basically remember this one. Next thing is, this is the important one. Understand? This is what we were supposed to discuss exactly. That is insertion of dielectric in between the capacitor plates when battery is not connected. Okay. If I say, for example, this is a parallel plate. Okay. This is one plate. This is another plate. Now I'm inserting the dielectric. This is the dielectric slab. Okay. So I'm inserting the dielectric in this case. So battery is basically not connected. Afterwards, what happens with, I'll tell you, what happens with its energy when battery is not connected. What happens with its electric field? We need to discuss this one. What happens with the work done? How much will be the work done exactly by external agent? Yeah, then we'll have to discuss when battery remains connected. Understand? This is what we are supposed to discuss. You got the feel now? Everybody understanding properly? It's gonna be okay, okay. That's great. You have class today at 8 o'clock, okay? We'll be solving the previous year questions in that class itself. Now see, let's solve this question over here, okay? This is insertion of dielectric in this case. You just tell me one thing. What is the first thing that we do? See, what happens over here? Initially, this, remember this theory, whatever I'm saying over here, the points, whatever I'm saying, okay? Now listen to me very carefully. This is a polar plate, this is a polar plate capacitor. Initially, this is not charged, no charge on this one. We connected the battery to it, okay? We connected the battery to it. We connected the battery to it. Okay, we connected the battery to it. What happens? This will take the electrons from here and will place it on here. So now it is charged. There is Q charge on this one. There is minus Q charge on this one. Now we remove the battery. When battery is not connected, afterwards, we say we removed this battery. Okay, this was the story till here. So we removed this battery. So what happens after that? On this plate, we say negative charge. On this plate, we say positive charge. Now, that's why basically I told you first we connected the battery. Afterwards, you'll say, sir, if there is no battery connected, how the positive charge is on this one? Have the negative charge on this one? So I gave you the answer initially. That's why. So positive charge, negative charge. We started placing the dielectric. What happens when we place the dielectric? There will be polarization. This will get shifted. Okay, this is the negative charge from this side. Okay. This is positive. Fine. So this will be polarized. Negative charge will shift from this side. Negative charge will basically shift to this side, and positive charge will be, positive charge will basically shift to this side. Understand? Now, can we say that these negative charge, these positive charges will attract these negative charges? So means this side of the plate towards itself 100% in the downward direction. So they will start attracting these. They will start attracting these with the electrostatic force, with the electrostatic attraction. Understand? Yes. So I can say that the net electrostatic, it will be toward in the downward direction, 100%. Now, case, what we are supposed to do, so that this energy, whatever it is to do in this case, we need to use the external force, understand, in the upward direction, so that it will come down slowly over here in between. Now, this was the scenario, this was the scene over here till now. We need to now basically discuss what happens with the energy. This is the first thing that we are supposed to discuss in this case. Now, listen to me very carefully. Okay, before this, let me tell you what happens with the capacitance. See, if I talk about the capacitance, whenever we place the dielectric in case of this, what do we say? Whenever we place the dielectric in this capacitor, in polar plate capacitor, what happens with the capacitance? We have to prove previously, that is capacitance will increase. So initial capacitance, if I say Ci, so final capacitance, if I say, for example, Cf, so can I say that is K times of Ci initial capacitance over here? This is the proof. Ci final capacitance after placing the dielectric, This will happen K times of C. C was the initial capacitance without the dielectric. Can I say it like that? This is the capacitance. This is the scene in case of capacitance. Now the second point over here is what happens with the charge. See, you are removing this. You are removing the stored will be exactly same. Okay. So it will, the charge will not increase, neither it will decrease. So it will remain disconnected the battery. So if, for example, Q charge is accumulated on this one, that will remain as it is. And on this one, Q charge is accumulated, that will remain as it is. Charge remains same. So can I say in this equal to Q final is equal to Q only 2 points 100%. Now, the third point in this case, what happens with the potential? Potential completely depends upon the battery. So in this case, potential will basically change. Initially, potential will be something. Finally, potential will be something. Because can I say in that case, potential, it is not the same. Potential finally is these, or how much the potential will decrease. Accordingly, we'll check it. So can I say this is the initial potential? Potential is what? C is equal to charge initially, that is Q, upon initial capacitance, I would say that is Ci. So what happens with the final potential? You will say, sir, finally potential is V. So charge is same Q, charge is same Q, finally also. So capacitance finally will be, that is Cf. Now in this case, can you just write this Q upon, what is the value of this Cf? You'll say, sir, this Cf is, what happens times of Ci. Can you just write it like 1 by K and Q by Ci. What is this Q by Ci? That is initial potential. Q by Ci, initial potential. So instead of this, I'll just write initial potential. Vi upon this K means this potential has been dielectric constant. If you place the dielectric case. What just happened? Is it fine now? Is it fine now? Is it fine now? I just need to know in the live chat itself. Is it fine? Is it fine? Is it fine, ladies and gentlemen? Come on, I just need to know, or is it still lag? Okay. Is it still lagging or is it fine? Come on. In the live chat itself. Is it fine, guys? Hold on a second, there is some issue with this network and all. Okay, guys, is it fine? Can I continue or I'll have to stop the stream? Come on. In the live chat itself, I just need to know as soon as possible. Okay. Now, so we say potential has been decreased by K times in this case finally. Okay. Initial potential was Vi and finally we basically derived. This has been reduced by K times when we basically place the dielectric in this case. Okay, that's great. It's okay. So we place the dielectric in that case. So this happened in that case. Now what happens with the energy? Okay, can you please tell me what happens with the energy? You'll say, sir, in case of this capacitor, we say energy is nothing but U is equal to Q square by 2C in case of this parallel plate capacitor. Now, initially, before placing the dielectric, when we have not placed the dielectric, understand? So, in that case, can you tell me what is the capacitance in that case? Initially, you'll say, sir, capacitance initially is, that is this potential energy initially is, that is nothing but this UI is nothing but, that is this Q square upon 2CI. Can I just write it like that? 100%. So finally, can I just write this? U final is nothing but, that is this Q square upon, charge remains same. Understand? Even if you disconnect this, battery charge remains same. I told you why previously. Okay. Okay, I told you previously why. So Q square upon 2CF. Can I just write it like that? You take this one. UF is nothing but, this is Q square upon 2CF. What is the value of CF? Final capacitance in this case. What happens? Capacitance already changed. Understand? This is after placing the dielectric, capacitance is increased by K times. So can I just write K times of Ci? So this will be nothing but K times of Ci 100%. So in this case, can I just write this? UF is nothing but Q square upon K times of Ci. So do one thing. This is 1 by K. I can just write it Q square upon 2Ci. So what is Q square upon 2Ci? That is initial capacitance. Initial capacitance. So can I just write this? Sorry. This is initial energy. So this is nothing but U final will come out to be 1 by K. And instead of this, I can definitely put UI. So can I just write over here, this UF will be nothing but UI by K 100%. So this also energy has been decreased by K times in this case when the battery is being basically what? When the battery is being disconnected. Exactly this happens. See, battery is basically charging it. Understand? Battery is charging the capacitors. Battery is that external agent which is doing the work done. And that work done is being stored as what? That work done is being stored as energy. Now you have disconnected that battery. Obviously that will decrease now. Previously I have told you, in case of if this was a charge at infinity, you are bringing it to another charge at this charge. At this point, you were doing the external work done in bringing this charge from this point to this point. So in that case, that external work done was storing as potential energy. Over here, in case of the capacitors, the battery is taking the charge from one of the plates and placing on the another place and charging this capacitor. So that's why we say in this case, this is the scene that happens, that this potential energy or energy is being decreased by K times in this case. Okay. Now, what happens over here with this? What happens with the electric field? Come on, in the live chat, can you hear me and see me properly? I just need the clarification. I'm still confused. Is it working properly? I hope it's not lagging now. Okay. What happens with the electric field? Can you guys tell me what happens with the electric field in this case? We know electric field is basically being decreased by K times. If I say, what is the electric field initially between the polar plate capacitors? We'll say, sir, that is sigma by epsilon naught. Because of one plate, it is sigma by 2 epsilon naught. Understand? By using the Gauss law, we can find electric field due to a charged sheet. Understand? By making that cylinder, by applying the Gauss law. And because of the another plate, it is also sigma by 2 epsilon naught, and it will be, because of the two plates, it will be nothing but sigma by epsilon naught. Exactly. Fine. Now, if I ask you in this case, can we write this in the form of sigma is what? Charge per unit area. That is nothing but Q by A epsilon naught in that case. Okay. Q by A epsilon naught in that case. Now, if I ask you what happens with the electric field, new electric field, you'll say, sir, that is being decreased by K times. So can I just write it is nothing but, that is E by K. E dash is nothing but, E final is nothing but, or E final E dash is nothing but, that is E by K. Exactly. So what is E? E is already, that is Q, this K exactly, and this A epsilon naught. So can I say this will be nothing but Q upon K A epsilon naught. This is the new electric field. Fine. Okay, let's move on to the next one. What is the work done in this case? This is one of the important expressions that you need to basically find out. What happens with the work done? What happens with the work done? What happens with the work done? Okay, what happens with the work done? Listen to me very carefully. If I say, for example, this is a plate, okay, this is a plate, this is positively charged, okay, and this is basically what? Negatively charged, negatively charged. You are inserting this dielectric in this case. When you are inserting this dielectric, this is force is being applied on this dielectric in the downward direction. That's fine. So because of this one, it is attracting this negative charge. This is attracting this positive charge, okay, in the downward direction, ultimately this. So we need to basically apply the force, external force in the upward direction. So means we are applying the force in upward direction so that it will come slowly down. So it will come slowly down. Can you tell me can you tell me in that case how much will be the work done? Understand? See, this is being, you are applying the force in upward direction. Can I say over here work done will be negative? See, work done by this external agent will be F external multiplied by that displacement. If I say, for example, that X negative, so this is in the opposite direction. So eventually this work done by external force, this external work done will come out to be negative only. Understand? So means over here system is doing work. We are just, you can understand it like this also. When we are placing this dielectric in this one, we are just holding this dielectric only. This is being pulled by what force? This electrostatic force, this, which is basically being created by these charges on these charges. Understand? So this is being pulled by this one. We are just only, that's why work done is coming out to be negative. So you might have studied previously, what is this work done? Work done is nothing but, this work done by external force is nothing but, that is change in potential energy. That is nothing but change in potential energy. Do you remember this from the electrostatics? If I say, for example, there is a charge over here, there is another charge that is at infinity. If I need to bring this charge from infinity nearer to this charge, for example, I'm placing it over here. So this is basically repelling this charge with the electrostatic force. So if we want to bring this charge nearer to this one, understand? So what we are supposed to do, we need to basically apply the force, external force. So our effort, our energy, our external force multiplied by displacement is stored as potential energy. So in this case, what is the change in potential energy? You will say, sir, U infinity, and over here, for example, UA. So can I say this much is the change in potential energy? So what that is stored as? That is stored as work done over here. The work done we are exactly doing. This I have clearly explained previously. If you have any sort of confusion, then watch the potential video. Okay? Then watch my potential lecture. Fine. So can you just tell me in this case how much will be the work done in this case? You will say simply, sir, change in potential energy. Understand? So that is UF minus UI. What was the UF in a final potential energy or final energy we recently got? That is how much? Okay. That is this. Can we just write this is 1 by 2 UI, 1 by K times of Q square by 2C. This is the final potential energy, or this is the final energy. Don't talk about the potential. This is the final energy and this is the initial energy. Can I just write in this case? Okay. Before inserting that. So this will be the final energy, that is Q square by 2K CI. Exactly. Q square by 2K CI means Q square by 2ci exactly. So in this case, can we take this q square by 2ci common? So it will be 1 by k minus 1 exactly. So this will be the work done. Okay. So you can just put this in this box. Fine. Understood? This happens with the work done. This much is the amount of work done in this case. Now the second point over here in this case is when the battery remains connected. When the battery remains connected, in that case, what happens? Okay. This is the next case. This is the second case. Okay, when the battery remains connected. You'll say, sir, in this case, the battery remains connected. In this case, the battery remains connected. So we are placing the dielectric in this one. Understand? So battery is connected. When battery is connected means potential will be same. Okay, that depends upon this one only. Positive, negative. In this, potential will be same. What happens with the charge? You will say, sir, first of all, let's talk about the capacitance. So what happens with the capacitance? You will say, sir, with the capacitance, whenever we insert the dielectric in this between the capacitors, capacitance increases. You will say, sir, capacitance final is nothing but K times of Ci. Ci is the initial capacitance, Cf is the final capacitance. Everybody give me the signal in live chat if you are understanding this properly. Or is it lagging? Is it lagging? Okay. Now, so this came out to be the capacitance. Now you will say, sir, what happens with the potential? Potential remains same because battery is connected. So can I say potential remains same? V final is equal to V initial is equal to V only. So potential remains same. What happens with the charge? Charge changes. Okay. Charge changes over here. You'll say, sir, how much amount of charge will change over here? I'll tell you how can you exactly find that. See, if I say this is a positive terminal, this is negative terminal. So this is a battery. So battery is still connected. Means this is extracting the electrons from this one and putting up the protons on the another plate. So means this is being charged with the positive charge. This is negative. So charge keeps on increasing. Charge keeps on increasing. So means charge keeps on changing. So how much charge will increase over here? That we need to exactly find. I'll just tell you how much that will be. So you'll say, sir, this is very simple. We can find it. Initially, before that, can I say charge is nothing but how much? Charge we say CV. Q is equal to CV. C is equal to Q by V. Capacitance is equal to charge by that potential. Q is equal to CV. What is the capacitance initially? That is nothing but Ci. V is what? Vi. Or you write either Vi because Vi and Vf are same. So that is nothing but this V. Okay. Now the point over here is, what is the potential finally? Charge finally. You will say, sir, charge finally is nothing but after that scene, inserting that dielectric. So this will be Q final. Charge finally will be nothing but Cf multiplied by this V only. Cf multiplied by this V only. Can I just write this? Qf will be nothing but, what is Cf? Cf is nothing but K of Ci in this case multiplied by this V only. So instead of this Ci, can I just put this Qi by V, 100%. So this charge Qf is nothing but Q of, instead of this Ci, I'll just put Qi by this V and multiplied by this V. This will cancel. So Qf will be nothing but that is K times of Qi. So means charge is being increased by K times, dielectric constant times. Initial charge was Qi. Finally, the charge is what? K times of Qi. Understand? So that's why I told you. So battery is connected, still extracting the electrons from this one, putting up the electrons on the another charge. Okay. So it keeps on charging. It keeps on charging. That happens over here. Let's talk about the electric field now. What happens with the electric field? Come on. Will the electric field change or will the electric field remain same? Over here in this case, if we say electric field is nothing but that is V by D. Okay. Electric field is basically V by D. Okay. This is what we are studying basically when battery is disconnected and when battery is connected. Okay. So in this case, can I say potential remains same because Vf is equal to Vi is equal to V only in case of when battery is connected? Yes. So D, distance between the plates, remains same. So can I say in this case, electric field will be also same 100%. Okay. This happens with the electric field over here. Let's talk about the energy right now. How can we exactly get the energy? Can you guys tell me in this case? In the live chat. Okay, this is the last one and we are done with this. Yes, 100%. What happens with the energy? Everybody understood till here? Is there any confusion? in the live chat, I just need to know all of you. Okay. Can I say in this case, electric energy initial is nothing but, we can write it in terms of energy, we can write in terms of like this also. U is equal to 1 by 2 CV square in terms of capacitance and voltage also. Understand? So can I just write UI is nothing but initially, that is 1 by 2 CI, and in this case voltage remains same, this potential remains same, so we say this V. And what is the final? You will say, sir, this final is nothing but 1 by 2, that is CF into this 1 by 2 CV square, and this will be V square. So VI is equal to VF is equal to V. When battery remains connected, in that case, this is the scene that happens over here. Now, can I say in this case, this UF will be nothing but 1 by 2. Instead of this CF, can I write K times of CI? So I'll just write K times of CI, and this will be V square. Why K times of CI? Because over here, because we know capacitance finally is increased by K times of CI. Understand? We have studied this previously. I hope this is working properly. So this UF will be nothing but, that is 1 by 2. And this will be CI and V square, and this I'll take this K as out. So can I just write UF will be in what? 1 by 2 CI V square, 1 by 2 CI V square. Instead of this, I'll put this UI multiplied by this K. So basically, this energy is being increased by K times when the battery remains connected. When the battery remains connected. When battery remains connected. Obviously, because this battery is only doing the work done, that's why we are getting this one. Okay. So, ladies and gentlemen, it was all about today. Thank you so much. It was nice interacting with you. It was all about today. Okay. So we say basically, apart from this YouTube platform, we teach on Unacademy's own platform. Sorry guys. Yes. I don't know why is it like that. I checked already the internet speed. That was fine. I don't know. Maybe some internal issue. Streaming issue. Yes. The video is lagging, I guess. Apart from this YouTube platform, I teach on Unacademy's own platform. Okay. And over there, country's top educators are basically teaching you. And if you want to learn from those educators, you definitely need to take this iconic subscription and this plus subscription. Okay. If you take this plus subscription, you will be getting live classes, weekly tests, structured courses, unlimited access. Live classes means every single day you will be getting the classes. Okay. And in this iconic subscription, you'll be getting all these benefits and this personal guidance, test analysis, experts guidelines, study material, study planners. And you can definitely follow me on Unacademy. This is my username over there. And these are the batches which will be starting from tomorrow itself. Okay, you can definitely enroll in these batches. And over here, I suggest you to basically go for this Shine batch. This is completely in English language. You can definitely go for this batch. Okay, you can definitely go for this batch. And Shine and the Spark batch. This is for JEE 2022. This is for JEE 2023. Next one is this. You can take this plus subscription for 3 months, 6 months. You can take it for 12 months, 18 months, and 24 months. If you take it for 12 months, by using my code, you can get the maximum possible discount and use my code. This is the price. EMI options are available also. Yeah. So this is the iconic, this is iconic, this is iconic subscription for 12 months, for 12 months, for 18, 24 months. Now, most important thing is, right now, discount is going on. Understand, you will be getting 10% of discount of this week's discount. Understand? And if you use my code, you will be getting extra 10% discount. By using my code, you will be getting extra 10% discount. So total of 20% discount. So if you are planning to take Unacademy subscription, so take it in this week only, I suggest you. And This is the Google form. You need to basically fill up. You will get the cash prize from Unacademy itself. This is a beautiful feature on Unacademy. That's Ask a Doubt. If you have any sort of doubt, you can basically ask. You can even ask unlimited number of doubts. You can ask the doubt anytime. You'll get the solutions, high quality video solutions. And how can you exactly ask this doubt? You can definitely take the picture. You can, that should be very clear. It should not be blurred. And post it on Unacademy, crop that particular doubt, and you'll get it within no time. You'll get the solution within no time. Thank you so much, ladies and gentlemen. I suggest you to basically subscribe to this channel, hit the bell notification as soon as possible, like this video and share this video. Thank you so much. See you guys tomorrow. Yes.